Hello all. So in today's lecture, we'll see how you can write a training pipeline for ANN, right? So ANN is this artificial neural network. Let's say this is an artificial neural network, and you want to write the training pipeline or training cycle for this. How you can write using PyTorch in that, right? So let's understand what are the components are going to be there in this pipeline. So we first define the model. So this is a model, right? So that my model looks like this. Now it is up to you to decide how it will look like. So this input and output layer will be defined by the the, the data you got, right? How many inputs are there, how many features are there, and what kind of output you want. Now, based on that, you decide this, and hidden layers are completely up to you. You want to use 8 neurons, 10 neurons, five hidden layers, anything is possible, right? So everything is up to you to decide. Now, for now, what we do in a training cycle is we run it for some epochs, right? Let's say some epochs, 5 epochs or something like that. We run it for that, and for each epoch, what we do forward pass, we do loss calculation, we do backward pass, and we do parameter update, right? Like we understood in autograde session that when I have a simple architecture, I do that, right? So I do forward pass, complete loss, backward pass, and I update the parameters. And then we'll see how we can evaluate the model and what are the changes we need to do in that. Then we'll see what is how we can improve the training using, let's say, some extra thing we can add on top of that is we can create a class of the model. So as of now, let's understand how the model we can define easily using, let's say, using the functions of this. Later on, we'll use something called nn.module, which will help us in creating a class object of that, and then that class will use to create objects, multiple objects, and then we'll train it. So it just helps in recreating the same object multiple, same class multiple times, right? So that's what this NN dot module will do. Now, sequential container will use. So initially we'll write it all by ourselves, and we'll see how sequential container will helpful in that. And after that, we'll do what kind of loss functions are there. So, for example, this is a binary cross entropy loss. This is cross entropy loss. There is something called mean squared error loss and normalize. So all the loss functions are there. We can directly import them. We don't have to write the loss function by ourselves. So that is that. Now, there's another library called torch.optim, which will give you optimize SGD Adam, Adagrad, whatever optimize you want to choose. You can go ahead and choose that. Now, how we can improve the training pipeline using data set and data load. So this data set and data load are another um, functions which will help us in loading the data, batching them, and shuffling sampling. So when we take the data, we want to shuffle them, right? And then parallelization, how we can parallelly compute the same thing, right? So maybe one batch is computing in, and another batch is also getting computed. Third batch is also getting computed. So it depends on number of workers you can assign. So parallelization also we'll see in this lecture, right? So if you know all this, then you more or less know how to write a training pipeline or training loop of the model. Okay. So let's import the initial function. So this import the torch I'm doing from torch dot I'm importing NN. Right? So this is another thing I'm importing. I'm importing diabetes data to so we'll make diabetes data. So this is a regression data, and we'll make a regression uh, model later on. Right? So let's first understand what this model look like. So we have this input layer, and then we have hidden layer, and then we have output layer. Okay. So how I'm going to define my input layer. So let's say I wanted to define the pre-activation layer, which is here, the hidden layer, the front part of the image in like that. That is the hidden layer. So I'll write nn dot linear, and how many inputs I'm getting. So you can see three inputs are going to the hidden layer. So that's why three in features and two. out features because that many I have neurons, right? So number of neurons will be decided by out features, and then I have to apply sigmoid on that. Now I don't have to define anything on like how many features input output because it's just an activation function which is on top of pre-activation. Similarly, I'll do same thing for output layer. I'll use let's say some two are inputs to this, and three is the output I want. So this is same as linear layer. Nothing is changing, but just I have to define it separate, right? And I have to decide how many neurons are going to be there in this layer. Now on top of that, I'm using softmax. So this is where I'm using a softmax. Now, mm, so this is my first thing, and this is my second layer with softmax. Now let's say, for example, let's take some inputs. Let's say I have this inputs where I'm taking four data points, and each of them have a size of three. Right? So this is how my data set is. Now, if I, of course, this is a rand n, so it will automatically generate different input. But let's set some manual seed to this manual seed, maybe 42. Mm, dot um, now, mm, yeah, same thing here. Now I have this layer, A1 layer. Now how will I do the forward pass to that? So I have to write this A1 layer I've created, A1 layer dot forward, and I have to give my data input as I said. So that's what I do. And it produce my pre-activation output. Now I have to apply activation function. So what I'll do, I'll take H1 layer, which is here, write forward and give my A1, which is here I've created. So A1 dot forward I've stored in A1. That A1 I'm giving here. And that's what produces H1. Now A2 layer dot forward I'll write and I'll give H1 to that and do it and so on. Right? So H2 layer. Now finally I got my softmax output. So this is softmax output. So you can see uh, some classes, but as of now we don't have any by proof, so I don't have anything to compare. But you can create it. So it says random data to understand how our class look like, and then we'll use this to build the model, right? So this is just to understand how you can define the architecture. So this is that's all for the architecture, how you can define it. So this defining a model part, you can do it very easily using this 4 5 lines of code. Now this is not the best way to write it, but it is that, right? So what we can do is on top of that we can have, let's say, sequential container, right? So we can do that. So for example, let's say uh, for network I'm storing nn dot sequential, and I'm storing all four layers into this, right? A1 layer, H1 layer, A2 layer, H2 layer. Now generally, so here I've already defined them, but most likely I'm not going to define them in this. So how I'm going to write it, I'm not going to write like that. I'm going to write like this. I'm going to define inside my sequential layer like this. Then please use C point after that, and I'll use my again linear layer, another one, and then I'll use softmax on that. Okay. Now this is I'm calling it network. So that's my network look like. Now I can directly say network dot forward, and I need to give X to that. So as of now, X is here. Yeah, I do not. So let's say if I do this, and you can see the outputs are coming in. Right? So it might be different because my A1 layer and A2 layer are initializing some weights, right? By default, and it will do it randomly. Like it will not do produce consistent result. So that's why my output could be different. but you get the point that you can write a sequential container. Inside this, you will put all of this and do it. So, what is the why it will be helpful, right? So you can see I wrote I need to create four variables first to define the model. Here, I need to define using one variable name network. That's what I'm using, and inside that, I'm putting all of them together. Now I have to run all of them individually, like A1 layer, H1 layer, A2 layer, H2 layer, and so on, right? So I need to run it individually, but here I just need to run it once with X, and that's all right. So it makes your work easier to do this. Now, if you wish to see what are the parameters are there in the in the network, you can directly do like network dot uh, parameters. Right? So you will get a generator kind of object. So it means it has stored in this, but you can access it by some means. So one way is you can write print and give star to in front of that. You can access the generator object like this. Another way is you can write a loop also for params in network parameters, print params. It's just one of other way could be this. Now these are the parameters for each of them. Right? So in order, like this is for the A1. This tensor is for A1. This is for um, A. It should be for sorry, this now what goes requires grade 2, requires grade 2, and um, okay, so these are the parameters um, for the first layer and second layer. So these are the weights for that, and this is the bias for that. And again, these are weights and these are biases, right? So what you can do, you can import torch.summary from summary. You can give your network and you mention what is your input size. So in this case, we have three. So in that case, we have first linear layer where eight parameters are there. Second, our sigmoid layer have no parameters, and then another linear layer where nine parameters are there. So total 17 parameters are there in this architecture. Okay, so you can get uh, that number of parameters and all from that. Now, let's say I have this data x comma y. I'm loading the derivatives data. I'm having x dot head, y dot head like this. Okay, so this is how my data looks like. Now, I'm doing as of now. Let's do it using sklearn. But later on, we'll make a data set and data loader class for this. We'll not choose sklearn later on. But as of now, for understanding, we'll do that. Now I have this split into X-ray index test. Now I have to convert all the data into torch, right? So PyTorch I have to, or tensor I have to convert that. So for that I'll run this. Now this is you can see X train. Right? So X train is like this. Um, should it's mentioned that that's something. So that's all. Now I have to take the shape of this. It's train not shape or actually what I'm doing is I'm taking how many columns are there. So for that I'm using the first index of that. Right. Now whenever I create my um, model, I can do that. So let's do the sequential container only. So I can like create this container and then inside this I can define it, right? So if I do that, then I do need to define all these layers and all, which will make our task difficult. Like this, I have done it to show you that it is difficult. Now with sequential layer or sequential container, you can put all of this inside this and it's a model, right? So this is a better way to build a model. Now, yeah, so I just need to do model dot forward and give my X string, and if I do that, uh, this, I'll get this output. Now, this is I can call as kind of you can call y hat or y prediction, anything like y hat. Okay. So that's how it looks like. Now, if you notice something that my white train is like this, it's a 1D array, and this is a 2D array, right? So like this, right? So it's a 2D array. Now, to s- to make it 1D, so that we can do the loss computation, all right? Otherwise, we'll get some, we'll not able to do correct computation. We can write squeeze function here, squeeze, and if I do that, you can see it is now a vector. So that's what we can do here. Now, these are my parameters, model parameters, and like this. Now, now let's do this part first. So we have let's say training pipeline. We have defined the model. So this is my model now. I've used it for three epochs. I'll use learning rate of 0.01, and and I have to write a loop for epoch in epochs. I'll do forward pass like this, y hat model dot forward and giving my train data, and then I'll do compute loss. So loss computation. So as of now, I'm using nn dot m as mean squared error loss, right? So what you can do, you can search something like nn uh, or PyTorch loss functions, right? So in this, you will be able to get the loss function. For example, here, right? So here we have some loss functions in this. You can see MSE, cross entropy, some other loss functions which are in VC, binary cross entropy, then Huber loss, soft margin loss, and then so on, right? So these all loss functions are there. You can directly import them and use them. So that's what I'm doing here. I am importing my loss functions here directly and computing the loss using that loss function and printing it, right? So that's what I'm doing. I'm doing a backward pass for that. And then I have to update a parameter, but I have to write toss.nowGrid, and inside that I'll update the parameter. So for each params in moderate parameter, update it using this set. So update params minus param dot grid. So if I have to write like this to do this. Now, after every cycle, one cycle is over, I have to make them zero, right? So, there is one inbuilt function given in the NN module by the library itself that you can write dot zero grid, and it will do the same as whatever we used to write grad dot zero in place function we are using, but this functionality is inbuilt given for given by pointers, so we can use this. So making gradients zero. So next time it will compute from zero, and whatever gradients we get, we will update that. Right? So this is a training cycle of my um, architecture. So if we are getting lost like this, we are reducing it by little, and later on we can improvise. We'll have multiple cycles in this, right? Multiple epochs running into this, and we haven't seen what is optimizers yet and how we can use them. So that's all we'll do in the next video. We'll do that how we can do the rest of the thing. Right? So we'll do model evaluation, how to do that. We'll improvise the training pipeline. So we have improvised using sequential container, but we haven't used any other activation function maybe, and we can use some other loss function also. So that's all improvisation we can do. Other improvisation we'll use some optim. Uh, we'll use some optimizers in this. And another thing we'll do is we'll uh, create this understand what is this data set and data load classes in this. Okay. That's all for today. Thank you.